All right, I can see some people are still joining, but we can get started now. Welcome and thank you everyone for joining us today for the Risk and Return on Investment webinar. My name is Kirsten MacMillan and I'm a climate resiliency specialist with the Climate Risk Institute. And I'm joined here today with my colleagues, Christine Zimmer from Credit Valley Conservation and Kerri Robinson from EOR. Claire Sanders from the Climate Risk Institute is today's Zoom host. So if you have any audio or technical issues, you can message her directly through the chat or send a message to hosts and panelists. And please note that we are recording the webinar today and we'll send out a link to everyone who has registered after our meeting. I'm joining today from Toronto on the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat people, and is now home to many diverse First Nations, Inuit, and Métis people. Today, we're going to be talking about some technical topics like climate change, land use changes, and water quality. And I think with these topics in mind, it is even more important to reflect on the history of the land that I am on and that you are on, and the many nations who have and continue to be its caretakers. At the Climate Risk Institute, we are continually trying to improve our knowledge, processes, and relationships so that we can better highlight and integrate Indigenous perspectives and knowledge of climate change into our work. So I'd like to invite you all to think about the territories that you are joining here from today, and please take this opportunity to introduce yourself into the chat so we know who is attending. And I'll just give people a little bit of time to do that. And as you're typing in your introduction, I can also introduce our presenters and speakers. So first, we're going to hear from Christine Zimmer, who is Chief Specialist, Watershed Projects Division at Credit Valley Conservation Authority. Christine is recognized as an expert in integrated climate risk management and adaptation strategies for watershed management and green infrastructure. She has worked with over 75 private and public sector partners to implement over 25 green infrastructure demonstration sites. Christine is committed to sharing CVC's leading edge research and technologies, having spoken at more than 40 conferences, reaching over 6,000 professionals and community members throughout her career. And thank you very much for joining us today, Christine. And next, we'll hear after from Kerri Robinson, who is a water resources engineer at EOR. She has 17 years of water quality and stormwater engineering experience in Canada and internationally. She specializes in supporting municipalities to develop and implement sustainable stormwater management practices through policy and facility designs that uses natural materials and methods. Located in Alberta, Kerri was a key contributor to the City of Edmonton's River for Life water quality strategy, low impact development guidelines, and LID construction, inspection, and maintenance guide. She has experience designing, constructing, and inspecting sustainable stormwater management features to minimize the negative impacts on the environment, downstream facilities, and surrounding landscapes. So thank you again for joining us today, Kerri. So this webinar is going to be 60 minutes. We're going to have our presentation from Christine, a short break, and a presentation from Kerri, and then we'll have a question and answer period with any time we have left remaining. For the time being, you can also use the Q&A function, so you can ask your questions in the Q&A, and it helps us to keep track as we're going along. We may answer some of these written as we're going, or take some of them at the end. So with that, I'm going to pass things over to Christine Zimmer, who will start us off with an introduction on the risk and return on investment tool.
Great, thank you. Good afternoon today on a Friday. Today's presentation, I'm just going to walk you through really quickly. We're going to start talking about some challenges and opportunities just to provide some context as to why we developed the risk and return investment tool, how we have used the risk and return investment tool within the Credit River Watershed. The Credit is a great living lab, and I'll cover that in a little more detail. I'm going to give you a highlight of the risk and return investment tool, some of the results and features and lessons learned that we've had in using the risk tool in the Credit River Watershed. as an optimization and a system-based approach to flood resiliency. And then how it's been used to integrate solutions across departments and organizations. And then Kerri's going to get into the water quality module and how it's being used to support asset management decisions. So I think some of the key challenges that I think all of us across Canada face is increasing pressure with respect to budgets and the need for transparency, accountability. The approach now, there is resistance to increase taxes given the economic situation that we're in with inflation and cost of living. To look for cost savings, whether that's through deferral of capital projects, reducing programming and operational budgets. The challenge is that stormwater and climate change adaptation budgets were already tight before COVID, and now we're going to become tighter. And we also, in the stormwater industry, I've always said we're the silent cousin next to water, wastewater, always having to compete for tax dollars. And so those are challenges we're going to continue to face, and it becomes even more instrumental as to why we need to demonstrate return on investment for the decisions that we make or we're proposing when we're trying to compete for dollars. There are opportunities in capitalizing on some of the limited funding that is available. I think one of the great things that's come out, if you haven't seen it already, is in November, Canada's National Adaptation Strategy. It really emphasizes that systems-based approach. It supports climate change infrastructure's lens on looking at holistic, natural, green and gray infrastructure as solutions, looking at return on investment, and also having consideration and regard for social vulnerable populations and the extra services that may be needed to support them in some of the extreme events that we'll be facing. And the other thing that I think with the continued constraints with respect to budget, I think there is also a growing emphasis on and recognition that infrastructure asset management planning, we need to incorporate climate risk. And in Ontario Reg 588 is really an instrument for municipalities to look at their existing life cycle costing and future projected with climate change to understand what their level of service is and what their level of risk is. I think there is growing understanding of the implications that stormwater asset deficit has, and combined with climate variability and rapid urbanization, which is a good instrument and tool for us to then start to talk to our municipal CFOs, CAOs, have those discussions about the cost benefit of investing now rather than deferring that cost until there's a crisis. Okay, there we go. You may be aware that municipalities are roughly 60% own roughly 60% of infrastructure in Canada. So we really are, at the municipal scale, the implementer of the National Adaptation Strategy. And when you look at municipalities across Canada, we obviously have areas that were built without flood control, and those are areas that we're particularly interested in investing in. If we need that money to upgrade and invest our infrastructure, municipalities must consider GHG supply chain emissions, understanding their risk upstream and downstream to optimize infrastructure. Also need to understand life cycle costing. And one of the challenges has been, well, if we're going to use nature-based solutions, what are the life cycle costs? What are the performances if we're going to compare it to gray and green infrastructure? Also understanding the impacts across services due to failures or damages from property and infrastructure, erosion and flooding. What are those damages and how do we quantify those damages so we can build that business case for the CFO? And what's the return on investment for implementing that infrastructure? I think one of the things that we've seen, and I'll talk about a little further in credit, is in the past we used to say, adopt 20% retrofit across a municipality. But that really doesn't address the risks. And we really need to look at, if we're optimizing infrastructure, because we have limited dollars, we have to really target priority areas, and with a consideration for the social vulnerability and health, because that does impact overall corporate risk of a municipality. And as part of investment optimization of infrastructure, we really need to look at shifting towards integrated solutions. So including low impact development natural assets to help address some of the urban overland or erosion issues or water quality issues that we'll speak about. And it's not one or the other. It's also conventional infrastructure. There is a place for that. There's also a need, a growing need to have the operational budget to maintain these infrastructure. It's not useless. Can't drive your car without doing your oil changes. Same with stormwater management. And there's also a piece for emergency preparedness, outreach, and education. There also needs to be a shift across municipalities, so across a watershed jurisdiction, across lower tier and regional municipalities, as well as looking at private sector investment. So looking at targeting incentives for high risk areas. And again, the need for considering climate change and asset management, and looking at the co-benefits. So we know that we cannot meet net zero with building retrofits alone. We need to look at natural assets, green infrastructure, as our means of helping us get to net zero. I'm going to take a little bit of time now just to share with you the Credit River, where I'm from. So I work at the Credit River Conservation Authority. For those of you outside Ontario, we have 36 conservation authorities. And the Credit River is between Toronto and Hamilton. It's 1,000 square kilometers. And in our headwaters, we have small rural municipalities that are groundwater dependent. And as we go down the river, we have in the middle area, some of the fastest growing municipalities in Canada. And then at the outlet, we have a municipality in which 75% of it was built prior to flood control. And so it's a great opportunity to learn from, because we have the gamut of the different environmental challenges. Obviously, as you build upstream, it may also have cascading downstream impacts. So again, we have to be very cognizant and look at an optimization or a systematic approach. As I mentioned, I think, and this is no different from any other municipality in Canada, there are varying levels of stormwater service, depending on the age of development. And so, as I mentioned, at our lower portion of the watershed, we have municipality that was largely built prior to flood control standards. And then as we grow up, we have newer developments and newer urbanization. And so there are different complexities in dealing with adaptation. In the upper region, we have high groundwater, we have assimilate capacity drought issues, source water protection issues. In the sort of middle portion, you're dealing with development pressures, protecting natural assets, ensuring that you don't have downstream impacts. Those are all challenges while also retrofitting. So given that we have this complex watershed, we worked with our municipalities across the watershed. We have also worked with a partnership of over 44 partners in private, public, and municipal provincial perspectives. We've collected data from municipalities across Canada to develop the risk and return investment tool. So what is the risk and return investment tool? The risk and return investment tool, what we found is if we work collectively to target investment and optimize infrastructure, it really requires us to understand what is the cause of flooding, because regional municipalities deal with sanitary backup, lower tier municipalities in Ontario deal with urban overland, and conservation authorities are responsible for flood forecasting and warning of riverine flooding. So we all have a role, but we need to work collectively. And so we've each been individually doing modeling. We need to integrate it and understand, why is this property flooding? Why is the infrastructure flooding or eroding? And so what the tool does is it brings those models together, allows us to see what properties are at risk and infrastructure is at risk of flooding, so that we can then quantify those risks. So step 2 is to quantify the damages in infrastructure to understand where our risks are. So in this particular case, urban flooding is the dominant type of flooding, but in other cases where we've seen in rural areas, we've seen groundwater flooding being the dominant risk to basement flooding. From that, we can then start to look at priority mapping. And I think this is probably the most instrumental piece of the risk and return investment tool. It's a great visual tool to allow us to talk to the CFO, CAO, municipality, or our residents to say why we're taking money from one watershed or catchment and targeting it into another area. So this allows us to really target where we want to implement infrastructure upgrades. We also have a component of the tool that looks at social vulnerability. We can assess where we may have higher risks due to depth of flow and velocity of flow. We also have a pathogen mapping where we can say, okay, these areas might be higher at risk of pathogen loading. And then we also have a social vulnerability risk that allows us to assess social vulnerability. Once you can then target what your goals are, then you can start to look at different management options, based on whether it's riverine or urban overland, and start to look at what the cost benefit is. So we have different financial metrics that allow us to look at what the return on investment is, whether that's net present value or average annualized damages. We look at different cost implications. And then we can compare those solutions. And we also look at supply chain GHG optimization, with the end goal to look at, again, as I mentioned, an integrated approach to flood resiliency. So whether that's planning policies. So we've done a great job in Ontario of preventing people from building in the floodplain. And as a result, in many of our urban areas, urban overland flooding is the predominant type of flood risk, not riverine flooding. So planning policies play an integral instrument in reducing flood risk. We also know that emergency preparedness plays an integral role in safety and also preparedness, as well as infrastructure, gray or green, as well as protecting or land acquisition and conversion to parkland for optimization. So these are just some of the outputs that you'll see in the risk and return investment tool. So you'll see, again, that you can have, we'll have a visual tool of where you might see flooding for the different event scenarios. So we can run events, whether that's a 2 to 100 or future climate scenarios, to look at what the change or what the flood risks are. I mentioned groundwater, and we worked with the European Union. Often when we looked at groundwater monitoring, we get an average annual or seasonal, but that doesn't allow us to compare relative risk to riverine or urban overland because we look at it from an event-based. With groundwater, you have high groundwater table, not just when you have a rainfall event, but also in the spring with melt. And so looking at our monitoring data, we're able to now look at it from an event-based perspective. And in some cases, we see that we have a higher risk of basement flooding due to high groundwater. It also allows us to fine tune where we might have sanitary backup due to infiltration. There is also an urban overland assessment. For municipalities that don't have urban models, we have a GIS-based methodology which looks at physiography. So it's not event-based. So it's really more to help drill down and understand where you might have the risks, where you might want to do more detailed assessment. Where you do have a model, the risk tool imports that model, and you can really drill down to look at depth, velocity, and quantify those risks and damages. When you bring in the layer of urban overland and riverine flooding, you can then start to look at where might you have sanitary backup due to riverine or urban overland. If you have a sanitary model, you can also put that into the model, and we can, again, if we have depth and velocity, or depth and time of event, we can then start to look at what the damages are. for sanitary, urban overland, and riverine. The other key thing that the tool allows us to do, we worked with the University of Waterloo to be able to look at what infrastructure may be at risk of erosion. And this was a primary case for us because we had to evacuate in a couple of events, apartments and other areas because of erosion. And some of our municipalities, if you actually look at municipal costs and damages, infrastructure damages due to erosion are the predominant type of cause of municipally owned damages. So the tool allows you to assess for different storm events what erosion infrastructure risks there are. So again, I mentioned the priority mapping, and I think as you see from Manif's quote, it's really allows us to target and to explain to our taxpayers or to CFO or CAO why we're targeting a particular neighborhood with a particular tactic, whether that's outreach and rebates or whether that's actual implementation of infrastructure storm ponds or its land acquisition. One of the other things that we looked at is stormwater management ponds. So a storm pond is only as good as you maintain it. And you need to understand that all ponds are not created equally. Depending on what's upstream, they may have sediment load that is causing it to be cleaned out more frequently than others. And so Kerri is going to talk about that more than I will. But again, it's another instrument or another mapping tool that you can use to help prioritize investment and optimization of your stormwater infrastructure. One of the things that we've been getting into, again, because it's a mapping tool, allows you to look at where you have high flood risks, where you have existing parks, where you have natural assets, to then create connectivity. So double or co-benefits. You can acquire lands to increase parkland, but also enhance your natural assets, your natural heritage features. So double benefits and net zero benefits. And so that's been a tactic that we've been using in some areas. I mentioned that we have social vulnerability. So this layer shows where you have social vulnerable populations, and there may be key drivers in different municipalities. It's not consistent across the board. So in some of our areas, a key driver may be single family, seniors, low income. And then you can target those areas to say, okay, what type of public health or emergency preparedness mechanisms do we need to implement here? And in Mississauga, we're creating climate hubs to help with building resiliency in some of these high priority areas with social vulnerable risks. One of the features, again, is that it is a financial tool. So once we understand the depth, the time of event, we can then determine what the damages are. We can look at damages from a private perspective and a public perspective and combined. So one of the financial metrics is average annualized damage. That's recommended by FEMA to help understand what kind of reserves you might want to have. It can also be used to help set levels of service target for the future. We want to maintain average annualized damages over the future. And so what are the strategies we need to do that? As I mentioned, we have been applying the tool across our watershed. And so within Mississauga, we're using them to target where we want to create resiliency hubs as part of their climate change plan. We're looking at it from an emergency preparedness perspective to say, where are our fire stations, our police stations, our community centers? Are they at risk of flooding? Where do we need to put our evacuation centers? What are the long-term care facilities or schools we need to work on with respect to evacuation plans for flooding? And again, within the city of Brampton, we're doing just that. We're creating a school program for targeted high-risk areas to develop an awareness and evacuation planning for flood risk. So again, I mentioned that we have over 44 partners spanning both private, public, lower tier municipalities, all the way up to the federal government. And we could not have done this without that partnership. So I wanted to extend my thank you to them and to RBC, who is funding the risk tool being converted to a free desktop to be made available across Canada. So with that, I will turn it over to Kirsten.
Great, thank you, thank you very much, Christine. I think you showed a lot of different examples today, and we'd be happy to follow up. There's been a couple questions coming through that I've been answering, but maybe before we switch over to Kerri's presentation, which will focus on a new element of the tool, we wanted to do a quick poll just to gauge what people are thinking about in terms of risk and return on investment. So maybe Claire has just popped that up on the screen. So the question is, my organization or one that I work with is looking for opportunities to quantify risk and return on investment. And then the options are strongly agree, neutral, disagree, or strongly disagree. So if you're joining from a municipality or another CA, feel free to answer with your own perspective, or if you work in another field adjacent, maybe keep some of your colleagues in mind as you answer.
All right, I'll just give it another 30 seconds or so, and then I'll close the poll. Maybe less than 30 seconds. All right, I'm gonna end the poll, Kirsten. And
yeah, so
I will share results.
Looks like we're getting a lot of strongly agrees and no disagrees or strongly disagree. I think this really reflects what we are hearing as we talk about the tool, talk about risk more generally across Canada, that many people are trying to figure out this question of where the risks are and what they should do about it with limited amounts of funding. So I'm happy to chat more if people would like to share specific examples of what they're working on or what they're looking for. That would be great to hear in the chat as well. But with that, I'm going to pass things over to Kerri, who's now going to be talking about a new module of the tool that has been developed over the last year in our 4 organizations. So take it away, Kerri.
Thanks, Kirsten. Thanks, Christine, for such a great context to jump into. So I am, there we go. I'm going to talk today about the water quality module portion of the risk return on investment tool. As you'll see throughout my presentation, I refer to it as RROIT because it gets to be a mouthful when you say risk return on investment tool water quality module. So you'll see me referring to it that way, but it's the same thing. So we have been developing this water quality module as a planning tool to be implemented within RROIT. I wanted to just clarify before we dive in too deeply the difference between a water quality module and a water quality model. So the module that we developed is a planning tool. It uses a GIS base of analysis. It has simple inputs that can be supplied by any municipality. There's often options for just kind of numerical inputs if a GIS layer isn't available. It's easy to use and it's easy to understand what the outputs are in the GIS format, and its intended use is for decision making. Compared to a water quality module or model, this is a much different, has a much different intent and objective. A water quality model is multi-parameter. It incorporates many different complex processes. It requires monitoring data and other detailed data and assumptions. It requires a lot of experience to use it properly. It has detailed file outputs that need to be examined to get the required data out of them. And it's used generally to support design and other complex, detailed decisions that need to be made. And so just to put it in perspective, we're looking more at a higher level tool that facilitates planning and decision making at that level. So the tool is based on the University of Guelph's stormwater management facility maintenance prediction methodology. And this has been translated to use a geospatial analysis input. So what we're looking for in terms of information coming from municipalities is a land use layer, the pond drainage layers, and then some EMC event mean concentrations for what would wash off of the landscape during an event. And those are all combined into one GIS layer into the model. So I'll just kind of go through what that would look like so that you get a feel for that. On the left is the input land use layer, and on the right is the input pond drainage layer. So you can see this is information that's readily available. And these are layered over each other and clipped together. So this is an example of what that looks like after they've been merged. And you can see on the left is the pond drainage layer. And then on the right is how that's divided into different land uses. And these land uses each have a specific event mean concentration that's associated with them. And so these are values that are readily available in the literature, and they're incorporated into RROIT. We also offer the option in here to apply some mitigation measures, and this is based on a standard set of BMPs, and they each have a set pollutant removal rate or percentage. And so this is also built into the model, and the options that you can choose from for pollutant or for BMPs is set for you with these removal rates already embedded. All of these things can be overridden, but it's all set up as a default, so to make this a really easy to use tool. So as we look at those land uses that are in each pond drainage area, we can then compare an existing condition without mitigation options with various other mitigation opportunities, so that we can get a feel for what the results would be in terms of sediment loading. So what we're looking at is the percent of land use treated by the BMP, and then RROIT will automatically, the water quality module will automatically update the EMCs based on that. So it's a fairly simple input process. This is what comes out in that shape file that I showed you. When it's all merged together, you get everything put together. You've got your pond information, you have your land use type, your drainage area, the percent impervious based on land use assumptions, and then the event mean concentrations for total suspended solids and total phosphorus, which are based on the land uses and the mitigation measures that are incorporated. So in order to estimate those, the sediment loads that go to the ponds within these drainage areas, we look at some very basic inputs. So this is based on annual precipitation, not a continuous simulation. So it makes it faster to run, and just provides a very general overview of what that would look like. And so what we're looking at there is annual precipitation in millimeters, the bulk density of the suspended solids, which is pretty standard and likely won't need to change. And then the sediment load threshold, which is the percent of sediment accumulation within a pond before that pond needs to be dredged. And this is set at 5%, but this could change for any level that the municipality is using for its maintenance protocols. And then finally, there's a couple of different options for estimating total phosphorus. And these things are all detailed in the user's manual, but there's just kind of some basic defaults that are in here, which can be overwritten, but that just provide an easy to use basic estimation so that you can get results without having to know all the details of all of these items. So once we add that, the sediment protocols in with the pond drainage details, we get out from that a GIS layer that has the pond drainage layer that can be highlighted based on sediment load and years to clean out based on that load threshold. And these are all summarized also in a text file, but you can get this all in a GIS output. So this is one of the outputs that you could expect to see. This is years until clean out. And so this is based again on the volume of sediment accumulating in the pond based on the land uses that are contributing and any mitigation measures that have been applied in that pond drainage area. So each of those polygons is a pond drainage area and has a little bit of information about the pond itself contained within it. So we did a case study within the city of Brampton on a few of their stormwater management ponds. And the goals were to estimate the volume of accumulated sediment within the pond over time, estimate the frequency of pond cleanouts required based on that accumulated sediment, and then identify the impact of various mitigation measures on sediment loading. So these are the three catchments, and you can see that they all have different land uses. There's a couple of them with significant business areas. One is very built out at the C53, and T63 has a lot more green space within it. There's provincial highways on a couple of them, and then one of them is primarily residential. So that was T69. So these were the three pond drainage areas that we used for the case study. So this is what we would expect to, this is what we did see under existing conditions. And so you can see that we're getting the an estimate of the years until clean out without any mitigation measures applied. So so the mitigation options that we then tested against that existing condition were permeable pavement in the business corridor and bioretention in all three land uses. So this was the highways, the residential, and the business area. So you can see we applied 20% bioretention. So 20% of each of those land uses was directed through bioretention in our assumptions. And then 10% of the business corridor area was directed to permeable pavement. Now, these are just kind of not random, but we just applied them to check out what the results would be, but these can be changed. These are 100% user input. There's no default assumptions with these percentages. So this could be as detailed as having polygons of these drainage areas to the mitigation measures, or it could be, I'd like to see how much I'd like to apply in that drainage area. Let me try out a few different scenarios to see what that looks like. So really flexible in terms of how these mitigation measures can be applied. So this is what we see in the results. So you can see there we've got T63, T69, and C53 on the left with no mitigation measures applied. And we've got sediment loads. They're reported by volumes here because that's what we're using to determine the pond sedimentation rates. And then with the mitigation measures, you can see the reduction in the image on the right. And so you can see that there's a significant sediment load in C53, which is that very built out commercial area. And it experiences quite a significant reduction in sediment loads based on those mitigation measures. And then you can see how that applies based on what kind of land uses you have and what mitigation measures you're applying. So this is one output, and now you can change the scale of how you display this, but it's just as an example, you can see how you'd be able to compare these visually. This is the years until cleanout based on that sediment accumulation and the pond size within there. So this is, goes from 28 years up to 40 years. And I understand that there's often municipalities will have their own set limit on years until clean out, and this may extend far past that, but this information this is just a kind of a general feel for how soon you're going to start to see impacts of that sedimentation on your pond volume. So whether this is actually dictating how you're going to actually manage your pond, or is more giving you a relative feel for what ponds may be best served by mitigation measures in their upstream drainage area. And that's the more likely application of this. It's, like I said, a tool, not a model. And so it's not taking into account all of the very detailed factors, but it is definitely giving you a good indication of which ponds are most pressured from that sediment load. The other thing that this tool gives you is the phosphorus load, and this is based on its relationship to sediment loading. And so you can see here, the mitigation for phosphorus is again based on the removal rates from those BMPs. And you can see some significant reductions that are coming into these ponds. Obviously, with more targeted solutions upstream, you would get different removal rates, but this is just kind of based on those general mitigation measures that were applied at the beginning. So some very clear applications that we see for this tool moving forward is that really it's giving you that relative pond cleaning frequency, which is going to refine those life cycle cost estimates for the stormwater ponds in your asset management plan. It will also help you to determine kind of where to focus operational mitigation measures and potentially what areas that you're going to want to focus on for structural mitigation or capital projects. That's it's really a tool to just help focus where the attention needs to be paid. And then we're also looking at the impacts of climate change. And so because this tool is based on the annual precipitation, the impacts of climate change on the total annual precipitation is where you'll see this come into play. And so you can see here, it's been run on a sample pond, and based on the total annual precipitation, you can see the comparison and the increasing frequency of pond cleanouts as you kind of move into mid-century and late century climate scenarios. Right now, RROIT incorporates RCP 8.5. And so that's what this comparison is based on. And this is built right into the RROIT tool. And so you don't have to go and dig up that data. It's already in there. So these are the primary applications for this. And obviously, as you can see from all of the updates and tools that Christine talked about, we always have ideas for things that we can do in the future. And so some of the things that we've been talking about potentially adding, if funding becomes available, is to increase the mitigation options that you can choose for these pond drainage areas. And that might include operational measures such as street sweeping or CB cleaning or road de-icing activities. We could add sediment removal systems or grit separators, filters, vortex units, that type of thing. The other thing that has been identified as a challenge is that there's a lot of uncertainty around a lot of the defaults that are being used in here. And so just a measure of what that uncertainty is. Obviously, having just really basic geospatial analysis is not the same as having a water quality module or model, but it does still come with some inherent uncertainties that it may be helpful to define. And then the third way is to actually expand this water quality loading estimate to subcatchments. So kind of on the same scale as the examples that Christine showed, where you're able to really kind of identify which subcatchments are generating the most sediment, and then potentially use that to target where you're going to want a stormwater management pond or an LED facility, or to start to implement other operational measures, and where that would have the most impact on your on the contributions of your municipality to the receiving waters. So that's the summary of what we've been doing, and that's our latest tool. So I would love to take some questions and have a chat.
Great, thank you, Kerri. So we will have a good amount of time for questions. I have one already that I'd like to ask from the chat, but I just wanted to highlight a few things before we close out. As Christine mentioned in her presentation, this tool was initially developed to solve some of the problems in CBC watersheds, but we have, of course, heard that there's a lot of interest outside of CBC and across Canada. So our organizations are working together to develop a free desktop version of RROIT over the next 2 years. We are continuing to look for funding for this to make it possible, and then in the future we'll be able to offer more resources, tools, and support to users who are interested. So stay tuned and get in touch with us if you're interested in learning more. So we wanted to ask, for our own interest, we always have ideas about new things that could be added or how we could improve, as Kerri mentioned. So we were hoping to do a quick poll, which is to ask people where they are most interested in additional enhancements or additional features focused specifically on the water quality module. So that is up now. Which of the following enhancements to RROIT would you find most valuable? And you can just pick one. So developing additional prediction options in the tool, like predicting cleaning frequencies of oil grit separators, quantifying the benefit of new physical stormwater management measures for water quality, such as a swim pond, quantifying the benefit of new operational stormwater management measures like street sweeping, or creating a priority map for water quality, similar to what we saw for the riverine and urban overland mapping. Okay, I think we can close that one out. Claire, most people have answered. So what I'm seeing is number one is to create priority mapping for water quality, followed by benefits of operational measures, then additional prediction options, and then benefits of new physical measures. So that's really good for us. We're going to take that away and think a little bit more about what else can be done to improve or to add to what we have already done. So I have a more technical question for Kerri first off from the Q&A. How does the estimated volume of accumulated sediment using EMCs compare with estimates made using MECP loading tables?
So we did that comparison for these ponds, and it's very close. It's not exactly the same because it's using a different process. It's using a geospatial analysis, but it's very much aligned. It's kind of either side of that plot. So
great, thank you, Kerri. A few other questions that I saw in the Q&A that we tried to respond to just by typing, but maybe I can highlight and add additional comments. So one question was if the tool considers changes or increases of flood risk due to climate change. So we did show some examples for the other modules up front that Christine shared. Really, we think it's really important to be able to make the case with some of these climate change scenarios to think about increasing frequency and magnitude of extreme events, and even just being able to lay that out in a figure or a graph and show that these risks are likely to keep increasing over time, and what we do now will be more impactful in the future is a really, really useful tool to make the case for a climate change adaptation. So thank you very much for asking that question, and happy to provide a bit more on the technical side, but we tend to use current 2050s and 2080s time horizons, and the built-in functionality is for RCP 8.5, but you can also customize those values. There's a couple of questions about if the tool had been used in the prairies and what it would take to do in other watersheds. So that's really what we are working towards with having RROIT be open source and a free desktop version in the future. So stay tuned for more case studies and more runs in other areas. And I think those are all of the typed questions that I can see, but just wanted to ask if anyone would like to add their questions to the Q&A or anything else that you would like to share, Christine and Kerri. And if there's anyone else that does not feel like typing and you would rather ask, you could send raise your hand and allow you to unmute. And Aaron asked, what other areas in Canada are you aware of that are using RROIT? Maybe Christine, would you like to take that one to share some of the case studies that have been done?
Yeah, so thanks for that question. Again, because this was largely developed with Credit River Watershed, we are responsible for our municipal partners. And so when we have gotten external funding, we did a project in Alberta and we tested the tool there. And as Kirsten mentioned, we are really looking if you look at the NAS and the 3 to 5 year outcomes, we really see that the tool is really supportive of the pillars of the built and natural infrastructure NAS component. So it's our hope that we can look for funding to allow us to run the tool in other watersheds and other municipalities across Canada, and to make it an external free for service version of the RIS tool, because this tool was developed with data from across Canada. We had over 60 municipalities providing us with data. We also had the national benchmarking and other professional associations giving us data. So it is a tool that could be used across Canada. It is something we hope to. It certainly does support this optimization and system approach that NAS aims to work at. So please, if you are interested, it would be very helpful if you did reach out to Kirsten or I. We could look at opportunities to secure funding. We'd be happy to work with you. But again, we are aiming to hope to make this a free tool that you can all utilize.
Yes, and we should also add that we're currently finishing up a case study in Thunder Bay that Kerri and I have been working on.
Yes, that's right.
Yeah, with Aaron. So it's great to have you on the line as well. But always, there's always so much that we can learn from working in other jurisdictions and across Canada. Sometimes the similarities are more than we think, but also can always improve things as we identify different practices or different standards in various jurisdictions.
One of the things I did notice someone asked about was if the recording was going to be sent and if the slides were, and yes, they are. So if you missed the beginning part, don't worry. You missed me, so that's not a big deal. Kerri was much more exciting than me. So you will get the recording and you will get the slides.
Great, yeah, thank you for mentioning that, Christine. And we do have just a brief summary of the tool on the CRI website that you can see, but this is more informative than the paragraph we have there. And I see a comment in the chat to let you know about things that we're working on in the prairies. Absolutely. Thank you for mentioning that, Kara. So I think with that, if we don't have any more questions, it's hard to tell if someone is laboriously typing an amazing question right now and I'm about to shut them out. But I think we can close off a few minutes early today. And as always, you can get in touch with us. We'll include contact information in the follow-up email that you'll receive if you registered for the webinar. So I'd just like to thank Christine and Kerri for your great presentations and answering our questions here today. And thank you very much to Claire, who's been providing technical support and having the webinar run smoothly. And thank you everyone for joining us today and looking forward to seeing you again in the future.